Hello, hello. Hi, everyone. I'm so glad to have you all in today's session. Before now, we have looked at developing or constructing a dashboard on Power BI using just one data set. However, in real life situations, in real life scenario, it doesn't really work that way. What we always have in real life scenario is that we have multiple tables. And why do we have multiple tables? We have multiple tables in operational processes, or organizational processes, or retail processes, sales processes, or marketing processes to make things more efficient. So that's why we always have multiple tables. And when we have multiple tables, the process through which all of these tables talk to one another or speak to one another is what we refer to as data model. Just to bring it home, let me give an example. When a student is admitted to a university or to an higher institution, we give that student a matriculation number. So for the admin, that's the school. They take all students that are admitted, they give each person a matriculation number, and each person then has to go to the department. When that person gets to the department, what will be asked of that person is, what's your matric number? So when say, oh, my matric number is 100111, then they take this matric number and put it in the department database. You'd notice that every other information that is collected by the admin of the school is not needed in the department, because the matric number is what is representing all of the other information that is needed about that student. So if in the university database or university data table of all students, the student has given information about their O levels, their primary school experience, their father, their mother's maiden name, their father's phone number, their mother's phone number. The department does not need all of those. The only thing the department needs is, are you admitted? What is your matriculation number? So once they are able to verify the accuracy of that matriculation number, then voila, you can go on to the class. For the admin does not need to know if the student scores 5/10 in a test. The admin needs to know, but the admin does not need to have that information or to collect that information every semester. The person that needs to collect that information every semester is the department. So in the department has a data table that talks to the courses that the student is taking, the score of that student, the attendance. If the student is taking that course, what semester? Is it the fall? Is it the first semester? Is it the second semester? Is it summer semester? All of this is held in the department. But the information about the students or the data about the student's background is held in the admin of the school. You notice that we now have two tables. Tables of the students' courses, test results, exam scores, which are in the department, and the table of all of the students in the school, which is in the admin of the school. So we now have two tables that are efficiently holding different information. However, they can talk to one another. And how would they talk to one another? Through the matric number. So if, let's say, after 10 years, someone wants to get information or verify information about the student, the person comes to the admin, say, oh, this person says he or she has this result, want to verify. The only thing the admin needs to do is send the matric number to the department. We want to fetch this person's result. The department goes into their own database, fetches the results, then sends it back to the admin. So the two tables have now spoken to one another via the what? The matriculation number. So we have two tables that are able to communicate with one another. And this process through which they communicate with one another is what we refer to as data modeling. Why do we need to understand data modeling as data analysts, as business analysts? It is important to learn data modeling and understand data modeling because data modeling forms the foundation for many database application or database softwares. So if you are going to work in any company that deals with large big data, you have to be able to work with data modeling or do data modeling. So in today's class, what we are going to be focusing on is relationships and cardinality. We have talked about, okay, data modeling is the process through which multiple tables talk to one another, and the logic through which they speak to one another is what we refer to as the relationship, and the mathematical representation of that relationship is what we refer to as cardinality. So these are the concepts we are going to be talking about today. So sit back, relax, and just listen. Take your Jota, pick your pieces, get no work. So to bring it home, we are going to be looking at a data set, particularly it's going to be in a retail company, a retail setting. So this data set talks about a retail company that has several customers and they sell across several countries, several states in that country, and several cities in those states in that country. For this big company, the first touch point is for their customers to register with them. So once their customers register, they give them a customer ID. So this customer A comes, give person a customer ID. That's why on this row, we have Carol Jones with customer ID 000-001. That's the person's customer ID. So you notice that this customer table would house all of the information pertaining to that customer. So I can pick any row and that row will tell me about that customer. I can pick any row and it will tell me about that customer. I can pick any row and it will tell me about that customer because each customer will be unique, just like each student in that institutional example is also unique. You'd notice then that now we just don't want to have customers for customers' sake. Customers would order for products because we're a retail company. So when our customers order, it would not be efficient for us to have this data set that has the name of the customers and their information. The same data set housing the order of that customer. Why? Because once we start saying, okay, let's assume that, okay, we want to put the order here in another column. That, okay, this is the order. They will start to, what if the customer orders for 10 products in a day, whilst another one does not order anyone at all? Then this data set becomes very messy. And our data management process becomes poor and less efficient. So for us to be more efficient in our data handling, in our data management, then what we do is we create another table for order. So when we create another table for order, which is here, then each order that any customer places will be given an ID. But you would notice that a customer can have multiple orders. So The person has to be a customer before the person can order. So the order will be unique. So when this order comes, so which customer is placing this order? Because all of our customers are properly registered. So which customer is placing that order? What is the order date? So every information we're going to hold on this database or on this table is only information pertaining to the order, not information pertaining to the customer. However, you can already see that implicitly, because we have this ID here already, the ID of that customer here, implicitly, our information about the customer is already there also. It's just, so let's assume that we have customer, let's say we have customer, let's look out for this customer in that order table. So we want to look out for that customer on the order table. Yeah, this is the customer. The person made this order. So let me put it in yellow so that it will be easy to follow through. Let me put it in yellow and put the border around it so that it will be easy to follow through. So that customer placed this order, that customer number 3 on the customer table was the one that placed that order. So on the customer table, it is this guy, Nico Reyes. Nico Reyes is the one that placed, or he or she, let me see the person's gender. Okay, she's the one that placed that order. Nicole Reyes placed that order. Because we already have that customer's ID, implicitly, if I say this column is gender column, customer gender, if I say, okay, this column is customer gender, that's what I named this column, customer gender. Implicitly, because I already have this table that holds the customer's gender here, and this ID is already linked to that gender, I can easily say that, okay, copy and paste that the person is a female. Easily. Why? Because of this customer ID. So that is why I was saying that for tables to speak to one another, there has to be a link. And that link in this case is the customer ID. That link in this case is the customer ID. So in today's class, the major thing we're going to be looking at are, firstly, we're going to be looking at what we call keys. Keys. Next thing, we're going to be looking at what we call relationships, like I mentioned at the beginning. Then we're going to be looking at what we call cardinality. These are the major tenets of what we refer to as data management. So we are going to talk about data management. We have to learn what we call keys, we have to learn what we call relationships, and we have to learn what we call cardinality. All of these are used in Power BI. All of these are used in SQL. That's structured query language. All of these are used in PostgreSQL. So all of these concepts we are learning today are not just for today. They are actually very important if you want to proceed into database management. So please sit down, relax, and what? Bring out your jotter, like I said. So in this first video, I have introduced us to the concept of having multiple tables, which I've said that having multiple tables help us as organizations to be able to manage data efficiently, or as an analyst to be able to manage data efficiently. Then the next thing is We have talked about how tables speaks to one another or communicates with one another. I would say they communicate through what we refer to as relationships. And what then maps these relationships is what we refer to as keys. So in this example that we mentioned here, this customer ID is a key. So now there are two types of keys. We have what we call primary key and foreign key. Now, primary key in a table is a key where on that table, every element under that key is unique. Every element under that key is unique. So now, if you pick customer ID, you notice that customer ID is on this table and is on this table also. That's why I said that because customer ID is in both tables, that is the key that binds the two tables together. That's the key upon which those two tables can communicate, and we can then do our data modeling. So we have two tables. That's where we started from. We have two tables. These two tables need to speak with one another or speak to one another or communicate with one another. And for them to communicate with one another, we need a key. For this example we are looking at, this retail example, we have the customer table, which houses all of the customers of the organization. And we have the order table, which houses the orders in the organization. You notice that the only element that is in this table and on this table that can form the basis through which these two tables can speak together is customer ID. Because we already know that for each order, a customer has to place that order. For each order that is made. Because you have to be a customer before you make an order now. You cannot just be an anonymous and place an order. You have to first register with our company because before you can place an order. That is not always the case. There are some tables you meet where customer will not be the key. Our customer ID will not be the key. In the example that we started with, which is the matriculation example, matriculation number is the key between the admin table and the department score table. That's the key through which they speak with one another. Without the matric number, the two tables cannot speak with one another or cannot communicate with one another. So also, if we remove this customer ID from this other table, then this other table does not speak with this or speak to this customer table because they are just different, nothing to link them together. So keys are the columns or the variables that binds or through which two tables speak with one another. And we data analysts, we are very, very wise and very, very smart. So we already, before we create tables, we already know that, okay, which one is going to be the key? Because you cannot just create tables that don't speak with one another or speak to one another. There has to be a key that map tables to one another. There has to be a key that maps table to one another. And in retail setting, the easiest one is is customer ID. And in a school setting, the easiest one is the matriculation number or student ID. So now, you will notice that on this customer table, each customer will be unique. No customer can have two IDs, except there is mago-mago going on or there are hanky-pankies going on in the organization. No customers will have two IDs. So also in the school example, no students would have multiple IDs. One student to one matriculation number, one student to one student ID. So on that table where that key that is mapping two tables or mapping more than two tables, because it's not only just two tables that we can map together, we can map multiple tables together. For that key, that table where that key, all of the elements under that key is unique, then we say that key is a primary key on that table. Then on the table where all of the elements under that key is not unique, because Under this table, under the order table, a customer can have more than one orders. I want that one order. So I can order this morning. Still me, the same customer, can order 6 p.m. in the evening. Me, same customer can order very early tomorrow morning. So you can see that one customer can have multiple orders. But on the customer table, I cannot be more than one customer. I can only be one customer. So I have just one ID. So on the customer table, that customer ID is a primary key. But on the customer table, that other customer ID is the primary key. While on the other table, that customer ID is what we refer to as a foreign key. Because it is foreign, it is not primary to this table. We are just borrowing that key from another table so that we are going to be able to map those two tables together. You will notice that this other ID will be the primary key in this other table because other ID is unique, all true. So when you see a table and you see something that you can use to identify that table and it is unique, all true, then we say that is the primary key. But if we see another thing that we have brought from another table to that table, which is unique in that table where we brought it from, but it's not unique in where we are using it, then that key is a foreign key. So that's the first one. We have talked about keys. Then the next one that I want to talk about is about relationships. Relationships just talk about how two tables are related. And we have talked about how keys give us that relationship. So now, the logic through which this customer ID is related to this other ID is true. Customer ID, customer table is related to other table. It's true the customer ID because the customer has to order. And we have already seen that one customer can have multiple orders. So that's just it. So it can either be many orders to one customer or one customer having many orders. And that's just the cardinality that we have talked about. So cardinality is just putting mathematical rules to the relationship, which is one to many or many to one. So that's the next thing I want to talk about now. I want to talk about what we refer to as one to many and what we refer to as many to one relationship. In our basic mathematics, basic algebra, we learned about relationship in mapping. We call mapping. We have what we call one-to-one mapping. We have what we call one-to-one mapping. We have one-to-many mapping. Then we have many-to-one mapping. And we have many to. These are all examples of mapping. These are all examples of ideological mapping. You will have remembered. So these are what we call mappings. So one-to-one mapping. They are not really technical. So in our own scenario, we have two tables. So we have table 1 and we have table 2. If on these two tables, we have one key here, which is unique. The key is unique here. Let me use this. Sorry. Let me bring that out. So I have one key here. And I have the same key, and I have the same key here, where they are just unique in the two tables. Then what I have is one-to-one mapping. One-to-one. So let me give you an example. Let me give you an example of, so in our organization, we give cars to employees. So on the employee table, which houses all of our employees, It's just each employee is unique in our organization. So each employee, we've given them employee number so that they can be able to access their office. Now, we now have a table for the cars, the brand of cars that we are giving to employees. But we can, as yes, we're a big company, but we are not very big. So we cannot give more than one car to one employee now. So we only give just one car to an employee. So on that table, when we say, okay, maybe we gave Toyota Avalon 2006 XSLL model to employee 001. We cannot give the same car to another employee. So on this table for cars, which is here, so let's say this is the car table, which is the data table, and this is the employees table, which is the employee data table. The same employee that is there can only have one car. So when we want to map the two tables, it will be 1-to-1 because one employee cannot have more than one car. So that's what we refer to as 1-to-1 mapping. So even when we bring this key, this employee ID, if we bring it to a car table so that we can be able to map out the employee that we give that car to, it's still going to be unique because it's just going to be one car to one employee. However, let's take another example. Let's take another example where we have our customer and order table, just like when we're working with. So we have customer table here, and we have order table here. You notice that for each customer, let's say we have customer 005. This same customer 005 can make an order in the morning, I want to pick an arrow. The customer can make an order in the morning and still make an order in the night and still make an order tomorrow and still make an order another day and still make an order. The person can have multiple orders. So that's what we refer to as many, one to many, because one customer can have many orders. So if you flip that, you can also have many to one, just like we are flipping one to many and many to one. So if it's coming from, if you are mapping from customer to order, that's one to many. This same relationship, we want to map it from order to customer, that is many to one. And we can also have many to many, where we can have multiple people being related to multiple keys in another table. So just let me use a very interesting analogy. Maybe you are in a setting where you are in a country where there is polyandry and there is polygamy. Polygyny and polyandry, where a man can marry multiple women and a woman can marry multiple men. So a man can marry multiple women and a woman can marry multiple men. So on the men table, we have different ideas of folks that want to get married, right? In this case, because a woman can marry multiple men, so we have many to one. Because a man can marry, so let's say we have man A. So in this society, we have man A who has married many women. Then we have another woman. They say it can also even be the same person, one of those ones that this one has married, or another person. So let's say another person. So that one is let's say Z, woman Z. Also, picking multiple men here also. There are tables like that. So when you start analysis, you'll see many different stories. So that's what we refer to as many to many. And that's what we are just going to do today. That's what we are doing today. So we're going to be looking at, so fortunately, the the example we are looking at today does not have many to many. It only has one to many because we have one customer having multiple orders. So that's about that. So now we are now going to Power BI to see what is happening there. So on Power BI, I have put in the order table and the customer table. Those are the two tables I'm going to be working with. So I have the order table and I have the customer table. So let me delete this. I'm going to delete this from the model. I'm going to delete product from the model because I only want to use order and customer. So let me delete this from the model also. So I have customer table and order table. So if I go to my report view, I can see the tables. If I go to, this is my customer table, this is my order table. Like I said, this data is clean, so you don't have any issue. Then the next place that you have to go to is the model view. Because we are now working with data modeling. We are not working with just one data set. We're having multiple data sets. We want them to be able to talk to one another. Because if we don't model them to talk to one another, we would only be able to work with either of the two data sets. It's either we work with order or you work with customer, either of the two data sets, which would not give you optimal return when it comes to your insights. But once you're able to map the two tables together, then you have better shot at a great insight. So that's why we want to have the two tables to ensure then that, okay, they are talking to one another. So what we then do is we go to data modeling. So naturally, what Power BI will do for you is it would want to help you create the relationship. So it's very smart. So it will help you create the relationship. You already see, okay, oh, what is customer ID? What are the things that are common? Oh, that's already seen customer ID here. That's seen customer ID yet. Oh, I think this is how they are related. That's the same way. That's the same thing we want to do. But there are times that Power BI will not be able to help you with that. So what we just need to do is, pick our work ourselves. So we'll click on manage relationships. So notice I click this ellipse sign. You can click any of the two tables. Click the ellipse sign. Just click on this ellipse sign. Click on manage relationship. You can also click on this button here also. Manage relationship. See the same thing. So click on new relationship. Then you see from table to table. So which table are you coming from? From customer table to order table, then cardinality. You recall that we have said it is one to many. And even that we are coming from order table to customer table, and the key we are using is customer ID. That means that it will be many to one. But because we are coming from customer table where customer ID is unique, and we are going to order table where customer ID has many entries, then that's why we are using the cardinality one to many. And even that we are coming from, let me remove this. Let me cancel and start so that we can see. So let me pick from orders table to customer table. It will be many to one, not one to many. So that's why I'm trying to do it. But most of the time, I always love to use many to one to many because it's the same thing. It's just like we are flipping. So it's like basically the same thing. So nothing. So you pick on others, one to many, then you click on save. That's all. Then from any of the two tables, you can bring in information from the other table. That's just what data modeling allows you to do. So if I go to this view, the table view, then I can, from my other table, because my customer table will not really give me any insights. The major insight I want to add is on other table. The only thing I need is I want to be able to bring in information from the customer table and use it in the other table. Because on the customer table, each person is unique. Each person has their own gender. So it will not really give me much insight. But for my other table, I will be able to get insight about the gender of the person making the order. So that's what I want to do first. I want to make, so on this order table, I want to be able to get the gender of the person making the order. That's what I want to get. And you recall that on the order table, the only thing I can get is the payment details, not the customer details. So what I want to now do is that I want to be able to get the customer details. Since I have linked my tables together, so what I will then do is click, then I'm going to click on new column. I'll click on new column. Then once you click on new column, something will come up here. So you can see the name of the column. So you can name the column as customer gender. Then equal to, you type related. Related is the formula. Once you type related, you will see that because you have done the modeling before, it's easy for Power BI to say, oh, what is related to this table? Oh, it is customer. What are things that are under customer? You can see acquisition channel, age band. So what I need is gender. So I'll just go and look for gender, put it there, close the bracket, press enter. Simple as ABC. Then it will populate my gender. So you can see that before now, what I had was only the payment details and the customer ID. So this customer ID has helped me generate the gender of the person making that order without needing it in this table, or without necessarily putting it on this table from the beginning. I can do the same thing for customer age. Go to the new column, get the age, then do the same thing. Do the same thing. Just type related. Sorry, what's it called? Sorry. Yeah, type related. It will bring customers. Then I bring age band from that customer table. Let's assume that I want to pick up another. I want to pick in the channel through which we acquired that customer. Then I'll just click on new column. I want to pick channel through which we acquired that customer. New column, so I will rename that column. I'm going to click here, then I'll just say channel. Then I'll write related, put my bracket. So I want to look out for channel through which we acquired that acquisition channel. That's it. Close the bracket, press enter, and you're good to go. It's going to create the column, put that channel. So you can now see that on my report view, I'll just go to order and just say, okay, pick clustered bar charts, pick my bar chart, and say my total the order amount. Yeah, this is the order amount. I want to put it on x-axis because that's, so my y-axis will contain my level. So I then want to put the acquisition channel on y-axis. So because I have already done my work, it's easy. I'll just look for acquisition channel, which is this. I'll drag it to y-axis. Simple. You can see that on the other, what's it called? I can now do anything I want because I have mapped the two tables together. But before now, if you look at these two tables here, I cannot use them together because you see that I cannot be able to know the channel through which I acquired this customer because the only thing that is on this table is the payment detail. But I have that information on this table. So this table would then allow me to get that channel. How am I now going to bring channel to this table? where order is, because that's where I want to know which channel is giving me the best return. So the only thing I will do is I'm going to map each tables together. Once I map them together, then I am able to bring channel to other table. Then boiler, I have my results. So I can then say, oh, organic search gave me the highest return. Retail partner, oh, I think I'm not going to partner with anybody again because it's not giving me any results. Paid search, oh, wow. Social media, wow, social media is doing great. You can see, beautiful. Yeah, we're good to go. So every other thing we have learned so far about painting your design, making your design beautiful, then comes up after that. So the major thing we want to learn today is what we have seen so far. Thank you very much, everybody. So we have on our data on the training repository, we have some data set that we have made available. We have the customer Power BI data set, we have pharmaceutical Power BI data set, we have public Power BI data set. So click on all of these data sets. Just pick any two tables that you can work with. Pick any two tables, then map them together. That's just two data sets. Map them together, do some dashboards on them. So I'll be expecting those dashboards in the next class. Thank you very much, everyone. I know this is a very long one, so please, I crave your indulgence to ensure that you watch this video. If you have any question, just drop it on the YouTube message. We are going to reply your message. Thank you. Do have